Okay, so now let's see how to balance a chemical equation. So for this, we must have a chemical equation. So let us write our previous chemical equation, which is uh, burning of magnesium. So magnesium combines with oxygen gas to form magnesium oxide. And as per law of conservation of mass, total mass in reactant or total mass of reactants must always be equal to the total mass of product. And that can be achieved by balancing the number of atoms of each element in reactant and product side. So let us try to balance this equation first. So we see that in product we have one magnesium atom, and in reactant also we have one magnesium atom. So it looks like magnesium atom is, so the number of magnesium atom is balanced so far. When we see oxygen, so in reactant side, oxygen atom, so there are two oxygen atoms here. We see O2, two oxygen atoms, and at this side we have only one oxygen atom. So oxygen, number of oxygen atoms are not balanced in this case. And in order to balance it, what we need to do, or what we can do, is we can put 2 over here. We're going to put 2 as a coefficient of this compound. Okay, we cannot put here because that will alter the chemical composition of compound. That then this compound is no longer magnesium oxide. Formula of magnesium oxide is MgO only. And as soon as we have written 2 as a coefficient before formula of magnesium oxide, now this 2 belongs to both magnesium as well as oxygen. So now we have two oxygen atom in product side, two oxygen atom at reactant side, but it has disturbed the number of magnesium atom now, because now we have we have got two magnesium atom in the product and only one magnesium atom or at the reactant side. So again we must balance this also. So for that we should put 2 over here. You see, two magnesium atom in reactant, two magnesium atom in product, two oxygen atom reactant, two oxygen atom in product, right? So this 2 belongs to both. So now this is balanced chemical. We will see. I will tell you the method how to balance this. This is just an example that I am showing right now. This is balanced chemical equation. So the method which I have used here is, I mean, this is not any specific method, and hence the name of this method is simply hit and trial method. So we have balanced this using hit and trial method, right? So we will use only this method to balance other chemical equations also. We are not going to use any other specific methods. Those you will study in your next grade. At this level, we are required to balance chemical equation only using hit and trial method. So for that, I will start with another example. So let us start with a new example and try to balance. So we will balance it together. So this reaction or the equation is written like this. So when iron reacts with water, it forms Fe3O4 plus it also forms hydrogen gas. So first of all, we know that number of atoms, we must always remember this line that uh, number of atoms of each element of each element must remain same on both the side, or must be same on both the side. I mean, both the side means towards reactant and towards product side. So now we have hydrogen element. So in reactants, what we have in this equation is iron element, hydrogen element, and oxygen element. And then the product will also have same type of element. So again, we have iron, oxygen, and hydrogen elements. Now, the number of atoms in iron is only one, Fe, only one Fe. And at product side, what we can see is there are 3 atoms of iron, right? So iron is not balanced. Then what about hydrogen? There are 2 atoms of hydrogen, and at this side, the number of atoms of hydrogen is 2 only. So it looks like it is balanced. So of course, the hydrogen atoms right now, they are balanced. And oxygen, only 1 oxygen at this side and 4 oxygen atom at this side. So oxygen is also, the number of oxygens atoms are not balanced. So now we will try to balance this, and to balance this we need to follow 2 rules. This is again, this is hidden trial method, and in this method also we are going to follow these 2 simple rules, which will make your life very easy. It will be easier to balance any given chemical equation using hidden trial method if you're following these 2 rules. And these 2 rules are, so the first rule, let me first put it down here. The first rule is, do not change do not change any of these numbers. Never try to change these subscripts written along with atom. They are the part of formulae, they are part of compound, and we should not change it. For example, this is H2O, which is water. And let us say if you want to balance this, there are 4 oxygen, and you just randomly put 4 here just to balance oxygen atom, so it won't be water. Now H2O4 is not water. Therefore, we should avoid doing these mistakes. So we should not change any number within the compounds itself. Within the compounds itself. That is to say, we should not change subscripts. Should not or must not change subscripts. Right? Subscripts are those numbers which are written at the bottom of these alphabets. So if we are not allowed to change subscript, then what we should do is we can change coefficients. Coefficient means we can add any number before these formulae. So we can change coefficients. This we can do. We can put any number over here, or in before any formula or element, we can put any number, but we should not change the subscripts. The next rule is, always start balancing the compound containing maximum number of atoms. Containing maximum number of So we must always start balancing that compound which has got maximum number of atoms. For example, if we are considering this chemical equation, so we have several compounds here, and we can see that okay, let's say water is a compound. How many atoms are there? So two hydrogen and one oxygen. That means there are total three atoms in this compound. What about Fe3O4? So we have three iron, four oxygen atoms. So total we have seven atoms in this compound, and here only two. So the compound having maximum number of atom in this case is oxide of this iron, which is Fe3O4. So we will start balancing that compound which has got maximum number of atom irrespective of position of this compound. That compound with maximum number of atom, it can be towards reactant side and it can also be towards product side, but we will always start balancing that compound only irrespective of its position, right? So let us start balancing this using these two rules. So again, on the next page, we will write that equation again. Fe plus H2O, and then write the products Fe3O4 plus hydrogen gas. So before balancing, what we are going to do is we are going to draw boxes. We are going to enclose all these reactants inside box. I'll tell you the reason why we are enclosing them in box. You need not to do it once you are familiar with the process of balancing. But before that, these boxes will help you to avoid committing mistakes while balancing. So now we have these all our compounds, both reactants and products, enclosed inside box. Now we are not going to touch any number which is inside this box, right? So 3, 4, 2, 2 here, and this 2 here, 1. So if nothing is written, that means 1. So we are not going to change these numbers. So this is the first rule, and hence we have logged those numbers inside box right now. We are now going to choose that compound which has maximum number of atoms. So now we are going to use second rule, and using that rule we found that Fe3O4 has maximum number of atoms. So let us change the color of this box so that we can concentrate on this. Changing, I'm hoping that this box is visible. So we have three atoms of iron in Fe3O4 and we need to balance it. Now let us see here. What we have got is we have got only one atom of iron, and in order to balance it we should have three atoms of iron towards reactant side also. So to make it 3, we will write 3 just before Fe. So it makes 3Fe. So now we have 3 atoms of iron. Alright, so iron is now balanced. Now the next atom in this compound is oxygen, and there are 4 atoms of oxygen in this compound, and we need to balance it. And here towards this side, towards reactant side, we have only one atom of oxygen, and this is present as part of a water molecule. So to balance this 4 atom of oxygen in Fe3O4, we must write 4 just before H2O. Now this 4 now belongs to all the atoms which are present inside box. So the 4 belongs to this H2 also, and 4 also belongs to oxygen atom. So as soon as we have written 4 before H2O, it makes 4 atoms of oxygen and how many atoms of hydrogen? So in compound itself there are 2 hydrogen atoms. Now we are taking 4 such compounds. That means 4 H2O. Let me try to explain these things. 4H2O means there are 4 H2O molecules. 4H2O. You see, if something is written like this, 4H2O, it means we have 1H2O, 2H2O, 3H2O, and 4H2O. So now in the 4 molecules of H2O, what we have got is 4 atoms of oxygen and 8 atoms of hydrogen. So basically, you just multiply this coefficient with the subscript and you will get the total number of hydrogen atoms. So we have 8 atoms of hydrogen. Now this is balanced. So 4 oxygen, 3 iron. What about other atoms? So after balancing this, now we will see all the atoms are balanced or not. So here we have 2 hydrogen atom, and this side we already have 4 hydrogen atoms in H2O molecule. Now in order to balance hydrogen atoms, so basically we have overall we have 8 hydrogen atoms at this side, and here only 2 hydrogen atoms. And to balance this, what we should do is we should write 4 in front of H2O also. Again, you will have to think all these things because this is just a hit and trial method. So you will have to be very conscious of these things, that how we should proceed to balance each and every atom. Those rules that I have told you in the previous slide, those two rules are, they are not any law, they are just simple rules that you may or you may not follow. If you are following that rule, it is going to make your life bit easier. Otherwise also you can, using your intuition also, you can balance these equations, but following those rule will make, of course it will make life easy. So now this is balanced. So balanced chemical equation will look like this. So now let me write the balanced chemical equation. So we will write 3Fe plus 4 molecules of H2O, and it gives Fe3O4, so 1 molecule of Fe3O4 and 4 molecules of hydrogen gas. So this is balanced chemical equation, right? Okay, we will see a few more examples of balancing. So first example, let us take the example of a burning reaction again, which is burning of methane, let us say CH4. So this is second example. So we have methane. So this CH4 is methane. When it burns, so burning takes place in oxygen. So it combines with oxygen and it forms carbon dioxide and water. So any fossil fuel, when burns, the major product is always carbon dioxide and water. Now let us first see whether the reaction is balanced or not. So let us see each element and let us count its number. So we have 1 carbon atom at this side, 1 carbon atom this side, 4 hydrogen atom, here only 2 hydrogen atoms, so it is not balanced. 2 oxygen atom, and at this side we have 2 oxygen in CO2 and 1 in H2O, so overall 3 oxygen atoms in product, 2 oxygen atom in reactant, 3 oxygen atom in product. So again oxygen atom is not balanced. So we should proceed towards balancing this equation. Now the first rule is we should not in fact change these subscripts. So to avoid that thing from happening, just put boxes, and we are not going to touch any number which are inside or enclosed in these boxes. Now find that compound which has maximum number of atoms. So I think it is CH4. It has 5 atoms, 4 hydrogen and 1 carbon. All other compounds have 3, maximum of 3 atoms. So CH4. So let me change the color of this compound, of this box. So it is CH4. So one carbon atom towards product. So carbon atom is balanced. What about hydrogen atom? So here we have four hydrogen atoms, and at this side we have two hydrogen atoms, which is a part of water molecule. Now to make it four, what we should do is we should write. So we already have two atoms. To put two over here as coefficient of. So take two, basically take two molecules of water, right? So we have one H2O and two H2O. It makes four hydrogen atom, right? Okay. Now, the moment we put two as a coefficient of water molecule, it makes two oxygen also. Two belongs to both hydrogen as well as oxygen. So right now this is balanced. Now what about other atoms or atoms of other elements? So let us take now let us see. We are left with oxygen. Here we have two oxygen, and at this side we have two here and two oxygen atom here. So overall four oxygen atoms at this side, right? So in order to balance this, what we are going to do is we are going to write. We will take that molecule where uh, the number is less. So this side has less number of oxygen, so we will increase its number and make it equivalent to the number of oxygen atom to its product by writing 2 over here. So to make it 4. So as soon as we have written 2 in front, as coefficient of oxygen gas, it makes 4 oxygen atom. Here also we have 4 oxygen atom, 2 from carbon dioxide and 2 from water molecule. Now this is balanced. So after doing all this thing, what we are going to do is we are going to just write it down neatly. So CH4 plus 2O2 gives CO2 plus 2H2O. Now using this is balanced chemical equation. Now using this logic, you try balancing. So this is for you, some questions. Balancing question. Balance K2CrO4 this is potassium chromate with barium nitrate BaNO3 twice. When it reacts, when potassium chromate reacts with barium nitrate, it forms barium chromate BaCrO4 and potassium nitrate, so KNO3. Okay. So now try to balance this using the same logic that we used in the previous two examples. So I will show you how to balance this chemical equation. You try first and I will show you in the next class how to balance this. Or I can even show you here also. What you can do is you first pause this video and try to balance it and then see the solution. So what we have got over here is we can, by hit and trial method, we can find that this compound has maximum number of atoms. So one barium, 2 nitrogen and 6 oxygen, right? So this again, this 2 in subscript belongs to both all these um, elements which are present inside this bracket. So 6 to 8 and 1 9, so overall 9 atoms. Others have less than 9, so and hence this compound has maximum number of atoms. Now we are going to balance atoms of this compound. First, barium. So we have one atom of barium. Look for barium atom towards product. We have one atom of barium, so barium is balanced. What about nitrogen atom? Two atoms of nitrogen. Towards product side, we have one atom of nitrogen. So this is not balanced. And in order how to balance, how can we balance it? by. So first let me put those boxes. Now in order to balance this nitrogen, what we need to do is we need to add a number in front of this, and what that number should be 2, right? This 2 makes 2 nitrogen. Here also we have 2 nitrogen. Now the next atom is 6 oxygen in barium nitrate. And how many atoms we have got over here? 4 and see 3 oxygen atoms in KNO3, and there are 2 molecules of KNO3. So overall, how many oxygen atoms? 3 times 2, which is 6. 6 here, oh, sorry, 6 plus 4, 10 this side, and this side we have. So here we have 6, and also we have 4 oxygen this side. So there are 10 oxygen atoms this side. So it is already balanced oxygen. 6 plus 4 in reactant side, and 6 plus 4 this side. So overall 10 oxygen atom and 10 oxygen atom, both sides, it is balanced. So all the atoms of this compound is now balanced. Now let us see other atoms. We have potassium here, 2 potassium. This side also 2 potassium, it is balanced. Chromium, 1 chromium this side, 1 chromium only this side. This is also balanced. Oxygen is already balanced. Nitrogen and barium is balanced. So now it is balanced. And this reaction, what we did is just by writing 2 over here, the whole equation got balanced. So at the end, we will finally write the balanced chemical equation. So K2CrO4 plus BaNO3 twice, it gives BaCrO4 barium chromate CrO4 plus 2 molecules of KNO, potassium nitrate. So this is balanced chemical equation. So we are done with this topic of balancing chemical equation. If you want, you can try other chemical equations also. There are several examples given in your textbook, and there are several questions also in your exercise given in your textbook. So you can try those, and if you feel any problem, then let me know through comments. In the next class, we will see different types of chemical reaction.